Download this code from codegive.com, link in the description below. Optimistic locking with F-core concurrency tokens, a detailed tutorial. This tutorial will delve into optimistic locking and how to implement it effectively using concurrency tokens in Entity Framework Core, F-core. We'll cover the concept, the rationale behind it, the code examples, and potential considerations. 1. Understanding optimistic locking. Optimistic locking is a concurrency control strategy used in database systems to manage concurrent updates to data. It's optimistic because it assumes that concurrent data modifications are infrequent. Instead of explicitly locking records for exclusive access, like pessimistic locking, optimistic locking allows multiple transactions to read a row, then checks if the row has been modified since it was read before applying any changes. Why use optimistic locking? Improved concurrency. It allows many users to read and potentially update data simultaneously. This can significantly enhance application responsiveness and scalability, especially in scenarios with a high volume of read operations and relatively few conflicting updates. Reduced overhead. Avoids the overhead of constantly acquiring and releasing locks, which can be computationally expensive. Simpler implementation. Generally, optimistic locking can often be simpler to implement and manage than pessimistic locking, as it doesn't require explicit lock management. When is optimistic locking a good choice? When concurrent updates are rare. When performance and responsiveness are critical. When you can gracefully handle concurrency conflicts when they arise, example by notifying the user and allowing them to retry. When is optimistic locking not a good choice? When concurrent updates are very frequent, leading to many conflicts and retries. This can actually reduce performance compared to pessimistic locking. When data integrity is absolutely critical, and even rare conflicts are unacceptable. In such cases, a more aggressive pessimistic locking approach might be necessary. When the application cannot gracefully handle concurrency conflicts. 2. Concurrency tokens in F-core. F-core provides built-in support for optimistic locking through concurrency tokens. A concurrency token is a property in your entity class that F-core uses to detect if the data has been modified since it was last read. The most common type of concurrency token is a row version or timestamp column in the database, which automatically updates its value whenever the row is modified. However, you can also use other properties, such as a simple integer version number or even a composite of several properties. How it works. 1. Reading data. When an entity is read from the database, F-core tracks the current value of the concurrency token. 2. Updating data. When you attempt to update an entity, F-core includes the original value of the concurrency token in the where clause of the update statement. For example, 3. Concurrency conflict. If another transaction has already modified the row since it was read, the row version column will have a different value. Consequently, the where clause will not match, and the update statement will affect 0 rows. F-core detects this and throws a db update concurrency exception. For handling the exception, your application code must catch the db update concurrency exception and handle the conflict. Common strategies include retrying the update, refreshing the entity from the database and retrying the update operation. Notifying the user, informing the user that the data has been modified and allowing them to review the changes and retry. Rolling back, canceling the current operation. 3. Code example, implementing optimistic locking with concurrency tokens. Let's create a simple example using a product entity. 3.1. Define the entity ***. Explanation asterisk. Asterisk timestamp attribute asterisk. This attribute explicitly tells fcore that the row version property is a concurrency token. It's typically applied to a byte property, which maps to a row version, SQL Server, or timestamp, other databases, column in the database. Asterisk byte row version asterisk. The byte type is important for row version / timestamp columns. These columns automatically update their value on every update to the row. The column cannot be explicitly modified through the code. Important notes on convention asterisk. Asterisk fcore by convention automatically discovers properties called row version or timestamp, case insensitive, and configures them as concurrency tokens. If you use a different name, you'll need to explicitly configure it in your DB context. Asterisk row version and timestamp are typically used because they are updated automatically by the database when the row is modified. 3.2. Configure the DB context asterisk asterisk. Explanation asterisk. Asterisk use SQL Server, your connection string, asterisk replace your connection string with your actual database connection string. This configures fcore to use SQL Server as the database provider. Adjust the provider based on your database type. For PostgreSQL use NPGSQL, for SQLite use SQLite, etc. Asterisk on model creating. Asterisk the onModel creating method is where you can further customize the entity configuration. In our case, the convention of row version is enough, but if we had named the concurrency token something else, example myVersion, we'd need to explicitly configure it using modelbuilder.entityProduct.property, p equals p.myversion, is row version. This tells fcore that the myVersion property is a concurrency token. Make sure to import Microsoft.Entity Framework Core if you are using these configurations. 3.3. Example code, updating a product and handling concurrency conflicts. Explanation asterisk. 1. Simulate concurrent update asterisk. The code deliberately creates a concurrency conflict by having two separate DB context instances. DB2 first updates the product's price and saves the changes. Then, DB1 tries to update the product's price without knowing about the change made by DB2. 2. Try, catch block asterisk. The code is wrapped in a try, catch block to handle the DB update concurrency exception that is thrown when the concurrency token doesn't match the database. 3. DB update concurrency exception handling asterisk. Asterisk ex entries single, asterisk. This retrieves the entity entry object that caused the exception. The entity entry provides access to information about the entity that was being updated. Asterisk entry.reload, asterisk. This is crucial. It reloads the entity from the database, overwriting the current values in the product1 object with the latest values from the database. This gives you the chance to inspect the changes made by the other user and present them to the current user. Asterisk entry.get database values, asterisk. This retrieves the values that were actually in the database at the time the concurrency check failed. This is also helpful for comparing the original, current, and database values. Asterisk user notification asterisk. The code includes placeholder comments to indicate where you would typically display the conflict information to the user, example in a pop-up dialog. You'd show the user the original values, the current values they're trying to save, and the values currently in the database, allowing them to decide how to proceed. 4. Handling concurrency conflicts, strategies and considerations. The most important part of optimistic locking is how you handle concurrency conflicts. Here are some common strategies. Asterisk retry with latest data asterisk. This is often the simplest and best approach if the user's changes aren't complex. Reload the entity from the database, apply the user's changes to the reloaded entity, and try to save again. The user may need to re-enter some data, but it avoids overwriting other users' changes. Asterisk merge changes, three-way merge. This is more complex but can be useful if you need to preserve both the user's changes and the changes made by others. You'll need to compare the original values, the user's values, and the database values to determine how to merge the changes. This often requires a dedicated merge algorithm and careful consideration of data dependencies. Asterisk overwrite database, last write wins. This is the simplest approach but is generally not recommended unless you have a very good reason to discard other users' changes. It can lead to data loss and inconsistent data. If you choose this approach, make sure to inform the user that their changes will overwrite any existing changes. Asterisk cancel and inform user. Asterisk if the conflict is too complex to resolve automatically, simply cancel the operation and inform the user that their changes cannot be saved. This is a safe approach but can be frustrating for the user. Key considerations. Asterisk user experience. Provide clear and informative messages to the user when a concurrency conflict occurs. Explain what happened and offer them clear options for resolving the conflict. Don't just throw an error message and leave them confused. Data dependencies. Consider the dependencies between different properties in your entity. If one property depends on another, you may need to handle concurrency conflicts more carefully to ensure data integrity. Transaction scope. Use transactions to ensure that all operations within a unit of work are atomic. If a concurrency conflict occurs, you can roll back the transaction to prevent partial updates. Retry logic. Implement retry logic with appropriate backoff strategies to avoid overwhelming the database with repeated failed updates. Don't just retry immediately after a conflict, wait a short period before retrying. Logging. Log concurrency conflicts to help you monitor the frequency and severity of these events. This can help you identify areas where you may need to adjust your concurrency control strategy. 5. Alternative concurrency token types. While row version and timestamp are the most common, you can also use other types of properties as concurrency tokens. Integer version number. You can use an integer property as a version number. Your application would need to increment this number whenever the entity is updated. You would manually update this in code. Composite concurrency token. You can create a concurrency token using multiple properties. This can be useful if you only want to detect conflicts if certain properties have changed. In this case, fcore would include both the price and description properties in the where clause of the update statement. A DB update concurrency exception would be thrown if either property has been modified since the entity was read. 6. Conclusion. Optimistic locking with fcore concurrency tokens is a powerful technique for managing concurrent updates in your applications. By understanding the concepts, carefully implementing concurrency token properties, and providing robust exception handling, you can improve performance, enhance scalability, and ensure data integrity. Remember to consider the specific needs of your application when choosing a concurrency control strategy and implementing conflict resolution logic. Choosing a good database design and database operations will also reduce the need for handling complicated concurrency conflicts.